Hello class, today we're going to look at finding the length of an arc. Alright, and these are talking about arcs of a circle. And before, when we saw arcs, we were looking at the measure of the arc, which is looking at how many degrees does it rotate. Alright, this time we're looking at how long is it actually. How many inches is it from here around the circle to there. Alright, inches, feet, whatever it is. But before we get into arcs, we're going to look at the circumference of the circle as a whole, the whole thing. And just a reminder, circumference is pi times the diameter, or it's 2 times pi times the radius. Right? So real quickly, we want to find the circumference of a circle that has a radius of 9 centimeters. Well, since this gives us the radius, we're going to use the 2 pi r formula. So we plug in the 9 for our radius, which gives us 18 pi, which we stick in our calculator and we get approximately 56.55. So this is in centimeters, so about 56.55 centimeters. Now we're going to find the radius of a circle given the circumference of 26 meters. Well, since they gave us the circumference, we're still going to plug in circumference, but we don't know the radius. So we'll plug in the circumference. 26 equals 2 pi r, divide both sides by 2 pi, and you end up with 4.14, and this is in meters. So 4.14 meters. All right. Simple enough. So I want you to work these two out, pause the video, solve the problems, then come back and check your work. All right, let's see how you did. Number 1. Should have gotten 15.71 inches, and number 2 should have gotten 5.41 feet. If that's what you got, great. Fast forward a little bit to the next screen. If not, we'll go over this. So it gives us diameter, so we're going to use the pi times diameter formula. Plug in 5 for d and 5 pi. Stick it in your calculator, you get 15.71, and it's in inches, so 15.71 inches approximately. Alright. Next we're looking for the diameter, so we're still going to use pi times diameter, only this time we're plugging in for circumference and solving for diameter. So 17 divided by pi, which is approximately 5.41, and this one was in feet. Alright. So simple enough, y'all been doing that for years, right? Okay, so now let's get into arc length. With arc length, what this is, the length of the arc is actually going to be proportional to the arc measure. All right? So the length of the arc as a ratio of the circumference, so this little piece over the whole thing is equal to the degrees of this little piece to the degrees of the whole thing. All right? Which makes sense, right? You've got half a circle, it's going to have half as long around it. You got a fourth of the circle, be a fourth of as long around it. So you got two things. You can either set it up as a proportion, the length of the arc over the circumference, 2 pi r, to the measure of the arc over the degrees, 360 degrees for a whole circle. Or you can set up the arc length, basically you just multiply both sides by 2 pi, so it's the measure of the arc divided by 360 times 2 pi r. All right? So let's take a look at this. First we're going to find the length of arc AB. Since we're finding the length, we're going to use the formula that says arc length all by itself. So we take the arc length equal to the measure of the arc, here's the central angle, so that's the measure of the arc, divided by 360, so this piece over the degrees for the whole thing, times the circumference, 2 pi r, r is 8. Yeah. And you can just take that, stick the whole thing straight in your calculator, and you get approximately 8.38 centimeters. All right. Here we're going to find the circumference, and it's a little weird to find it with over here, so we're going to put it in that proportion. All right? So we have the length of the arc over the circumference, the length around the whole thing, equals the measure of the arc in degrees over the measure of the whole circle. All right? Plug in what we know, arc length, arc measure, solve for C. So this is just cross multiply and divide. You can simplify the 40 over 360 first if you like, but it's not really necessary. You just cross multiply, divide by 1, and you end up with 37.71 inches. All right? Now C, here we're finding the measure of the arc. And we are talking about the minor arc, not the major arc. If it wanted the major arc, it would have to have a point here saying go the long way. All right? So for C, we're going to use the same proportion here. All right? So the measure of the length of the arc over the length of the entire around the entire circle equals the measure of the arc over the measure of the entire circle, which is 360. All right? Plug in what we know, which in this case is the length of the arc and the radius. Work this out. Okay. Multiply by 360 to both sides, and we end up with approximately 165 degrees. All right. So what I want you to do is work out these three problems here. Pause the video, work them out, then come back and check your work. All right, so let's see how you did. Number 3, number 4, number 5. If this is what you got, congratulations. You can fast forward to the next little bit. If not, let's go over it. All right, so we're looking for the length of the arc PQ. So we are going to use this formula here. All right, measure of arc length of arc PQ equals the degree measure of arc PQ over the degrees of the whole circle times the length around the whole circle. Now in this case they gave us the diameter, so that's a little bit different. So instead of using 2 pi r, we're going to use pi times the diameter. So that is 9 pi. And the measure of the arc is 75 degrees. You just take that whole thing, type it straight into the calculator, and you get the length of arc PQ is 5.89, and this is in yards, so yards. Circumference of the circle. Well, this time it gave us the major arc, but that's okay because we have the degree measure for the major arc. The degrees can be over 180, that's fine. All right. This time we're going to use the proportion. So the length of the arc over the length around the whole thing equals measure of the arc over the measure of the whole thing. So plug in what we know. Let's go ahead and simplify that. Cross multiply and divide, and you end up with C equals 81.68, and it's in meters. Number 5, we are looking for the radius. So we're looking for R. So we're still going to start off with this proportion. Plug in what we know. We know the length of the arc. We know the degree measure of the arc. Use your cross products, so cross multiply and divide. We end up with this. And this time we've got 2 pi r over here. All right. So go ahead and work out that side here, and we have 25.2. Divide both sides by 2 pi, and the radius is 4.01 approximately, and it's in feet. All right. So what we're going to look at here, we have the dimensions of a tire. We want to know to the nearest foot how far will this tire travel if it makes 15 revolutions. So as it rolls all the way around 15 times. Well, when it does that, to go 1 revolution, if it's going to spin 1 time, every point on the edge of this tire has to touch the ground, right? And so if we're looking at the distance all the way around the tire, that's circumference. To find circumference, we need the diameter. So let's start with that. Diameter, we just add all those up, and we end up with a diameter of 26 inches. Okay, so if we know the diameter, we can get our circumference, because that's pi times diameter, so 26 pi. And we're going to leave it as 26 pi for right now. We don't want to round until the very last thing, because if you multiply by around it, if you round the number, it's a little bit off, and if you multiply it, it gets, that amount you're off gets multiplied, and you're even more off. So we don't want to round until the very end. So now we know how far it is around the tire once. So 1 revolution, how far the tire will go. We want 15 revolutions. So, very simply, all we're going to do is take the number of revolutions times the circumference, and that'll tell us how far we went. So 15 revolutions times the circumference of 26 pi gives us about 1225.2 inches. But this one's in feet. So we take our inches, we change them to feet, divide by 12 basically, and you have 102.1 feet. Except once it's to the nearest foot, so we round that off, and we have approximately 102 feet. All right, so not too bad. All right, what I want you to do is the same thing. Here we have a car tire of 28 inches diameter, so it always tells us that, and we want to know how many revolutions it's going to take to go 500 feet. I want you to pause the video, work this out, then come back and check your answers. All right, let's see how you did. Hopefully you got an answer of about 68 revolutions. If not, let's see why. All right, there you go. There it is. So first we need to know how far one revolution is. So pi times diameter. So 28 inches are diameter, so we have 28 pi inches. Now this is in inches, and our distance is in feet. So we either need to change our inches to feet or our feet to inches. I don't really want to divide my pi inches by 12 because it's not going to come out very well. So instead, I'm going to take my feet, multiply them by 12, and now I've got 6,000 inches. All right. Then, if that's how many inches I need, and this is how many inches one revolution will go, I can take total inches divided by one revolution, and that gives me 68.209 revolutions. So about 68 revolutions. All right. Now, what we have here, this is converting between degrees and radians. What a radian is, very simply, is just another unit of measuring degrees. All right. You'll go into more detail with this in a trigonometry class, but for geometry, it's just another unit of measure. That's it. It's like you can measure volume by gallons, or you can measure it in mass. You can use grams. Right? How much stuff do you have? You have this much stuff, or you have that much stuff. You have, gallons, and you have pecks, whatever. So, what this is, the conversion ratio is pi over 180. To go from degrees to radians, you take your degrees, multiply it by pi over 180, and you end up with radians. Or, to go the other way around, it's radians times 180 over pi equals degrees. Okay? So, not real hard. So we're going to convert 45 degrees into radians. So we have degrees, so it's degrees times pi over 180. So it's 45 over 180. We can kind of ignore the pi and just leave the pi there. Think of it like if this was x. It would be 45 over 180, which you would simplify as 1/4. So you have 1/4 pi, or pi over 4. Right? Here we're going to go the other way around. So 3 pi over 2 is in radians. We want to change that to degrees. So instead of using pi over 180, we're going to use 180 over pi. Right? Well, when you multiply like this, the pi's are going to cancel out, right? You have one in the numerator, one in the denominator. And so then it's just 3 times 180 divided by 2, which is 270. So you have 270 degrees. Right? So now I would like for you to do these two. Pause the video, work these out, and then come back and check your answers. All right, let's see what you got. So for 8, you should have gotten pi over 12 radians. And for 9, you should have gotten 240 degrees. Right? If not, let's take a look. So we're going to go from degrees to radians. So it's 15 degrees times pi over 180. So it's 15 pi over 180, like that. And then just simplify the coefficients, and you have 1 over 12. So 1 pi over 12 radians. Over here for the degrees, we're going from radians to degrees. So we take our radians times 180 over pi. And so the pi's cancel out. 4 times 180 divided by 3 is 240 degrees. And that is arc length. Remember, arc length is a proportion. The length of the arc over the length around the entire thing, the circumference, equals the degrees of the arc over the degrees of the entire thing, so 360. With radians, it's degrees times pi over 180 equals radians, or radians times 180 over pi equals degrees, depending on which way you want to go with it. And that's it. I hope this helps, and I will see you next time.